Form 1 work. Form 1 Mathematics. And our topic is divisibility tests. So, in this topic today, we are going to deal with how we are going to know that a number will be divisible by a certain number without necessarily going to divide that number using the long method. So we have divisibility tests that start from 2 up to 11. So we're going to deal with those divisibility tests, and right away I'm going to start with the divisibility test for 2. So we are saying that a number is divisible by 2 if that number, the last digit of the number, is either an even number or a 0. So divisibility for 2, it says a number is divisible by 2 if the last digit is either an even number or 0. So I can give examples of numbers that we'll know without having us to divide using the long method. We'll know that that number is divisible by 2. So I can give an example of a number, maybe let's say a number like 200. 200, without even using the long method, we will know that this 200 is divisible by 2 since the last digit here is 0. A number also like 152 maybe, the last digit there is 2, and we know that even numbers, examples of even numbers include 2, 4, 6 continuously. So we have that this number is divisible by 2 because the last digit there is an even number. We can give also so many other examples. Other examples maybe like 68. This is also an even. This number is also divisible by 2 since the last digit is an even number. So we can proceed now, going to the next divisibility test for 3. Maybe here I give examples. 152, 64, 150. Then we can go on. The next number is 3, divisibility test for 3. A number is divisible by 3 if the sum of its digits add up to a number that is divisible by 3. So we are saying a number is divisible by 3 if the sum of its digits is divisible by 3. So giving examples, we can give an example of a number. Let's say, for example, a number like 78426. Let us test if this number is divisible by 3. We are being told using the divisibility test is that a number is divisible by 3 if the sum of its digits is divisible by 3. So we are first of all going to test if this number is divisible by 3 by adding up the sum of the digits. So we are going to take, this is 7 plus 8 plus 4 plus 2 plus 6. So 7 plus 8, this is 15. 15 plus 4, 19. 19 plus 2, 21. 21 plus 6, this is 27. And as you can see, 27 is divisible by 3. If you take 27, you divide by 3, we get that this is 9. So we are going to say that this number is divisible by 3 since the sum of its digits are divisible by 3, or form a number that is divisible by 3, and the number formed after we've added up the sum of the digits is 27. So we can say that this number is divisible by 3. So you can be given a question like, for example, test whether a question like, which one of the following numbers are divisible by 3? So let's say let's call this question 1. Which of the following numbers which of the following numbers are divisible by 3? And the numbers that we are given there maybe are 574, we have 681, we have 24,381, and lastly we have 87,690. 87,690. So our question there, we are supposed to test which one of the following numbers are divisible by 3. So if we have to test, and we know that our divisibility test for 3 is that a number to be divisible by 3, a number should be divisible by 3 if the sum of the digits are divisible by 3 or form a number that is divisible by 3. So if we have 574, we start with this one. So this is 5 plus 7 plus 4. This gives us 5 plus 7, this is 12. 12 plus 4, this is 16. 16 is not divisible by 3. So 574 will not be divisible by 3. We go to the next one, which is 681. So this is 6 plus 8 plus 1. 6 plus 8, this is 14, plus 1, this is 15. So 15 is divisible by 3. Therefore, our number 681 is divisible by 3. We go to the next one. This is 2. Let us do it here. 2 plus 4 plus 3 plus 8 plus 1. So if we have that number, 2 plus 4, this is 6. 6 plus 3, it is 9. 9 plus 8, this is 17. 17 plus 1, this is 18. 18 is divisible by 3, yeah, correct? Because if we take 18 divided by 3, we are going to get the answer is 6. So our number 24,381 is divisible by 3. Then lastly, we have 8 plus 7 plus 6 plus 9 plus 0. So 8 plus 7, this is 15. 15 plus 6, this is 21. 21 plus 9, this is 30. So we have the sum there, 15, 21, yeah, 30. So 30 is divisible by 3. Therefore, our number 87,690 is also divisible by 3. So that is how we know that these numbers are divisible by 3. We've been told that a number is divisible by 3 if the sum of its digits is divisible by 3 or form a number that is divisible by 3. So that is how we deal with the divisibility test for 3. We can now go on with 4. We have 4. So we say that a number is divisible by 4 if the last two digits are either both of them 0 or form a number that is divisible by 4. So I can write that. So I've been told a number is divisible by 4 if the sum, the last two digits, if the last two digits of the number are both 0 or form a number that is divisible by 4. That is divisible by 4. So the divisibility test for 4 is a number is divisible by 4 if the last two digits are both 0 or form a number that is divisible by 4. A number with, for example, maybe e.g., we can give an example of a number, let's say 600. 600 is divisible by 4 because we have the last two digits are both zeros. Another number, it's maybe we can have 532. 532 also, we have that the last two digits, as we can see, we're being told that a number is divisible by 4 if the last two digits are both 0 or form a number that is divisible by 4. So our two digits lastly here are 32. 32 is a number that is divisible by 4 because if we take 32 divided by 4, the answer is 8. So that number is probably divisible by 4 because it forms a number that is, the last two digits of that number are divisible by 4. We can maybe go through a question. So test whether, we're being told to test whether 61,500 is divisible by either 2, 3, and 4. So question 2, test whether test whether 61,500 is divisible by 2, 3, and 4. So we have our question there. We have to test whether 61,500 is divisible by 2, 3, and 4. So we can reflect back as the divisibility test for 2 was the last digit should either be an even number or a 0. So as we can see our number there, 61,500, our last digit is 0. So meaning that this number is divisible by 2. Then by 3, we were told that if the divisibility test for 3 is that the sum of the digits should be divisible by 3. So we're going to add up. We see if it will. 6 plus 1 plus 5 plus 0 plus 0. So this gives us 6 plus 1, 7, 7 plus 5, so this is 12. 12 is a number that is divisible by 3, meaning that our number 61,500 is divisible by 3 also. Then lastly, we also have to test whether that number is divisible by 4. A number is divisible by 4 if the last 2 digits are both 0 or form a number that is divisible by 4. We have our number as 61,500. As we can see, our last 2 digits are both 0, meaning also this number is also divisible by 4. So that is how divisible by 4. That is how we tackle such questions. You don't have to go to use the long method to know if that number is divisible by a certain number. So we can also continue with the divisibility test for 5. So a number is divisible by 5 if the last digit of that number is either 5 or 0. This one is easy. So we can say a number is divisible by 5 if the last digit is 0 or 5. So if the last digit is 0 or 5. So we can know that a number is divisible by 5 if the last digit of that number is either 0 or 5. Let us try doing a question. So this divisibility test usually helps you to know if a number is divisible by a certain number without having to divide it using the long method. So we have a question. This is question 3 now. Question 3. We are being told which one of the following numbers are divisible by both 2 and 5. So our test here is to know if we know which of the following numbers are divisible by both 2 and 5. So let us see the numbers. We have numbers like 820, 41,325, 57,640, and lastly 68,068. So we have those numbers 1, 2, 3, 4. We have 4 numbers there. We are supposed to test if those numbers are divisible by both 2 and 5. We have our divisibility test for 2. A number should be divisible by 2 if the last digit is either 0 or an even number. So already we can start eliminating. We can say divisibility test for 2. The last digit is 0, meaning this one is divisible by 2. The last digit is 5. A number is divisible by 2 if the last digit is either an even number or 0. As you can see, 5 is not an even number. 5 is an odd number. Therefore, this number is not divisible by 2. So this is for 2. This one, the last digit is 0, meaning it is divisible by 2. And this one also, the last digit is 0, meaning it is divisible by 2. Next, we are supposed to find if the numbers are divisible by 2 and 5. So by 5, 820 is divisible by 5 because the last digit should either be 0 or 5. So 820, the last digit is 0, meaning it is divisible by 5. The other one, 41,325, it is also divisible by 5 because the last digit is 5. Then the next one, the last digit is 0, meaning it is divisible by 5. And the other one also, the last digit is 0, meaning it is divisible by 5. Therefore, in this question here, the numbers which are divisible by both 2 and 5 are 820. This one is not divisible by both 2 and 5. It is only divisible by 5. Therefore, it eliminates it from the answer. So this one is the only number that is not divisible by both 2 and 5. So we have numbers that are divisible by both 2 and 5. We have gotten that it is 820, 57,640, 684,320. So those are the numbers that are divisible by both 2 and 5. So let us continue now by finding the divisibility test. We are continuing with the divisibility test for 6. So a number for 6, a number is divisible by 6 if that number is divisible by both 2 and 3. So to know that a number is divisible by 6, you are supposed to look at that number if it is divisible by both 2 and 3. So we are saying a number is divisible by 6 if the number is divisible by both 2 and 3. So having that, we know that the divisibility test for 6 is a number is divisible by 6 if that number is divisible by both 2 and 3. And we already have divisibility tests for 2 and 3 here. So we were told that a number is divisible by 2 if the last digit is either an even number or 0. For 3, the sum of its digits should be divisible by 3 or form a number that is divisible by 3. So let us try maybe looking at a certain question here to make us understand more. So a question for divisibility. Which one of the following numbers are divisible by 6? Let's say this is a question 4. Which of the following numbers are divisible by 6? And we have numbers like 8,730. The next number 834. The next number 3,672. And lastly we have 6,732. So we have these 4 numbers. We are supposed to test whether these numbers are divisible by 6. And we know that a number to be divisible by 6, the number should be divisible by both 2 and 3. So let us start with 2. Let us test if these 2 numbers are divisible by 2. 2, the last digit should either be an even number or 0. So the last digit is 0, meaning it is divisible by 2. The last digit here is 4. 4 is an even number, meaning it is divisible by 2. The last digit here is 2. It's an even number, meaning it is divisible by 2. And the last digit is also 2, meaning it is divisible by 2. Now let us test for 3. For 3, the sum of the digits should form a number that is divisible by 3. So this is 8 plus 7 plus 3 plus 0. So this is 8 plus 7, 15 plus 3, this is 18. So 18 is divisible by 3. We go to the next one. This is 8 plus 3 plus 4. 8 plus 3, this is 11, plus 4, this is 15. So 15 is also divisible by 3. We go to the next one. This is 3 plus 6 plus 7 plus 2. So this is 9. 9 plus 7, this is 16. 16 plus 2, this is 18. So that number is also divisible by 3. Then lastly, we have 6 plus 7 plus 3 plus 2. 6 plus 7, that is 13. 13 plus 3, that is 16. 16 plus 2, that is 18. Meaning this number is also divisible by 3, meaning all these numbers are divisible by both 2 and 3. That tells us that all these numbers are divisible by 6. So we have this, we've tested that these numbers are both divisible by 2 and 3, and the divisibility test for 6, we know that the number should be divisible by 6 if the numbers are divisible by both 2 and 3. And as we can see, all these numbers are divisible by both 2 and 3. So they are all of them divisible by 6. So we can continue now. Divisibility test for 8. In the secondary school level, we do not have the divisibility test for 7. So we'll just we go to the divisibility test for 8. So let me write this way. Our today's topic was divisibility test. It's Form 1 work. We've already done divisibility tests for 2, 3, 4, 5, and 6. We're now going on to divisibility test for 8, sorry. So a number is divisible by 8 if the last 3 digits of that number form a number that is divisible by 8. So we can write that a number is divisible by 8 if the last 3 digits, form a number that is divisible by 8. So as we can see there, a number is divisible by 8 if the 3 digits, the last 3 digits of that number form a number that is divisible by 8. So we can give an example, maybe an example like so let us test that if that number is divisible by 8. So having that number, we are supposed to check the last 3 digits. The last 3 digits of the number are 144. 144 is 144 divisible by 8. If we divide this by 8, this is 8. Yeah, so we get that if we take 144 divided by 8, our answer is 18, meaning that this number 2144 is divisible by 8 because the last 3 digits which are 144, they have formed a number that is divisible by 8. So that is how we test if a number is divisible by 8. Just check the last 3 digits. If they form a number that is divisible by 8, then we are good to go. So let us see if we can tackle a certain question here. We are asked which one of the following numbers are divisible by both 4 and 8. So our question 5, which of the following numbers are divisible by both 4 and 8. So we have our numbers are 1120, 52,104, and lastly 7,368. So having those 3 numbers, and the examiner is testing us if we know the divisibility test for both 4 and 8. For 4, a number is divisible by 4 if the last 2 digits are both 0 or form a number that is divisible by 4. So let us look at our 3 digits here. We have 1120, so we start with 4. Let us see if that number is divisible by 4. The last two digits, so the last 2 digits there are 20. 20 is divisible by 4, correct? That gives us 5, meaning that 1120 is divisible by 4. Next, the last 2 digits, 04, that is just the same as 4, meaning that this number is also divisible by 4. Lastly, 68. 68 divided by 4, this is 128, 17. So meaning that this number is also divisible by 4, because if you take 68 divided by 4, you get it is 17. So the 3 numbers, as we can see there, are both divisible by 4. Are all divisible by 4. Now let us test whether they are divisible by 8. a number is divisible by 8 if the last 3 digits form a number that is divisible by 8. As for 4, we looked at the last 2 digits. For 8, we are going to look at the last 3 digits. So our last 3 digits here are 120. So is 120 divisible by 8? By 8, this is 1 by 8, 1, 40, 15, correct? So 120 is divisible by 8, meaning that this number is also divisible by 8. The next one is, this is 104 by 8, this is 1 by 8, this is 1. 24 by 8, that is 3, meaning this number is also divisible by 8. And lastly, 368 divided by 8. So by 8, this is 1. By 8, this is 4, 32, remainder 4, 48 by 8, this is 6. Meaning this number is also divisible by 8. So as we can see in this question, we were being tested if we know that numbers are divisible by either 4 and 8. We tested that this number is divisible by both 4 and 8. The other 52,104 was also divisible by both 4 and 8. And lastly, 7,368 was also divisible by both 4 and 8. So as we can see, all the 3 numbers there were divisible by both 4 and 8. So the only thing that we are supposed to know is how, if you know the divisibility test, you don't have to take the whole number and divide it by 8 or divide it by 4 so that you know if that number is divisible by either 4 or 8. The divisibility test makes it easier for you. So let us go on with divisibility test for 9. A number for 9. So as we say, a number is divisible by 9 if the sum of the digits form a number that is divisible by 9. It just looks like this one for 3. So I'm saying a number is divisible by 9 if the sum of its digits form a number that is divisible by 9. That is divisible by 9. So if you want to know that a number is divisible by 9, you have to first of all add the sum of the digits in that number. And if they form a number maybe like 9 or a multiple of 9, that means that those numbers will be divisible by 9. So let us look at an example. A number like so we have 594. Let us see if the sum of these digits will give us a number that is divisible by 9. So if we take 5 plus 9 plus 4, 5 plus 9, that is 14. 14 plus 4, yeah, this gives us 18, whereby 18 is divisible by 9, which gives us 2, meaning that this number is divisible by 9 because the sum of its digits have formed a number 18, which is divisible by 9. So let us have a question there to see if we've understood the divisibility test for 9 and if we can find a number that is divisible by 9 without using the long method. So we have a question. Test whether tests whether 875,610 is divisible by 2, 3, 4 by 2, 3, 4, 5, 6, 8 and 9. So in this question here, we are supposed to know all the divisibility tests starting from 2 up to 9 because the question is testing us to see if this number is divisible by 2, 3, 4 up to 9. So let us start with 2. Having our number 875,610, a number is divisible by 2, so let us test for 2. A number is divisible by 2 if the last digit is an even number or 0. So this, the last digit, as you can see, it's 0, meaning that this number is divisible by 2. By 3, a number is divisible by 3 if the sum of its digits form a number that is divisible by 3. So we are going to add, this is 8 plus 7 plus 5 plus 6 plus 1 plus 0. So 8 plus 7, this is 15. 15 plus 5, 20. 20 plus 6, 26. 26 plus 1, this gives us 27. 27 is divisible by 3, which gives us 9, meaning that this number is divisible by 3. We go to the next one. A number is divisible by 4 if the last two digits are both 0 or form a number that is divisible by 4. So the last two digits of the number, our number is 875,610. Our last two digits there are 10. 10 is not divisible by 4 because we are going to have a remainder 2. Therefore, this number is not divisible by 4. So we continue. Next is by 5. A number is divisible by 5 if the last digit is 0 or 5. Our last digit is 0, meaning that this number is divisible by 5. Next, 6. So to know whether 875,610 is divisible by 6, we know that the divisibility test for 6 is that a number is divisible by 6 if it is divisible by both 2 and 3. So by both 2 and 3, our number was divisible by 2, as you can see, and it was also divisible by 6, meaning that this number, by 3, meaning that this number was divisible by 6 because it was divisible by both 2 and 3. So we have our number is also divisible by 6. We continue by 8. Let us see if this number is divisible by 8. A number is divisible by 8 if the last 3 digits form a number that is divisible by 8. Our last 3 digits are 16. So we test whether 16 is divisible by 8. So if we take 16, so by 8 this is 1, by 8 this is 7 because of 56. 56, 50, 50. 50 will not be divisible by 8 because we are going to have it is 6 because of 48 remainder 2. So it will be 2 over 8, meaning that this number is not divisible by 8. So we continue, and lastly, we test whether the number is divisible by 9. A number is divisible by 9 if the sum of its digits form a number that is divisible by 9. So our number we're going to have, this is 8 plus 7 plus 5 plus 6 plus 1 plus 0. So this gives us 27 divided by 9. This gives us 3, meaning that this number is divisible by 9. So our number 875,610 was divisible by 2, by 3, by 5, by 6, and by 9. So the numbers that were not divisible by the number were 4 was not, and 8. But the rest of the numbers were both divisible. So as you can see there, we've already tackled the divisibility test for 2, 3, 4, 5, 6, 8, and 9. And having this question, it will not be difficult for us if we knew the divisibility test. And it has taken us a very short time to do it because we know the divisibility test. It will be harder if we were supposed to use the long method to find if this number was divisible by all those numbers. So let us now continue. Next, we are going to find, we were supposed to find the divisibility test from 2 to 11. So we have two more that are left. So the next was 10. Let us find if this number is divisible by 10. So 10. A number is divisible by 10. 10 is easier. A number is divisible by 10 if the last digit is 0, just that. So a number is divisible by 10 if the last digit of the number is 0. So to know that a number is divisible by 10, you just have to look at the last digit. It should be 0, not any other number. So numbers like, you can give examples, 120, 7,000, as long as the last digit is 770, as long as the last digit is 0, those numbers are divisible by 10. that one is more simpler. We can maybe try and look at a question. So, our question, which one of the following numbers are divisible by both 3 and 10? So, in this question, we are being tested if we know the divisibility test for both 3 and 10. So, our question is, which of the following numbers, are divisible by both 3 and 10. So our numbers are 270, 430, 510, 624, and lastly 720. So having these numbers, we are going to test whether they are divisible by both 3 and 10. So we start with 3. The divisibility test for 3 was a number is divisible by 3 if the sum of its digits form a number that is divisible by 3. So we start with 270. This is 2 plus 7, which is 9, meaning that this number is divisible by 3. The next one, this is 4 plus 3 plus 0. So this gives us 7. 7 is not divisible by 3. The next one, this is 510. 5 plus 1 plus 0. This is 6. 6 is divisible by 3. The next one, 624. 6 plus 2 plus 4. So this is 8. 8 plus 4, that is 12. 12 is divisible by 3. And lastly, 720. 7 plus 2 plus 0. So this gives us 9. 9 is divisible by 3. As you can see, all these numbers except 430 are divisible by 3. So let us find whether they are divisible by 10. A number is divisible by 10 if the last digit is 0. So we have this number is divisible by 10. The last digit is 0. It is divisible by 10. Also this one too. 624, it is not divisible by 10 because the last digit is 4, it's not 0. And lastly, 720. So we have that numbers that are divisible by both 3 and 10 are 270. As you can see there, it was divisible by both 3 and 10. 510, it was divisible by both 3 and 10. Next, 720 was both divisible by 3 and 10. But these numbers, 430 was not divisible by 3, and 624 was not divisible by 10, meaning that numbers that were both divisible by both 3 and 10 were 270, 510, 720. Let us look at the last one now. We have the divisibility test for 11. So for 11, it's a bit longer. We need enough space. So the divisibility test for 11. A number is divisible by 11 if the sum of the digits in the first, third, fifth, seventh position, those are the odd positions, and the sum of the numbers in the second, fourth, sixth, eighth, like the even positions, should either be equal or should differ by 11 or a multiple of 11. So we can write that a number is divisible by 11 if the sum of the first, third, fifth, etc. Like that one tells you that the sum of the first sum that we're supposed to add are the numbers in the odd position, and the sum of the second, fourth, sixth, 8th onwards. So in the even position should either be equal, the sum of that one and the sum should be equal, or should differ by 11 or a multiple of 11, or a multiple of 11. So this one is the longest one, but it's not hard as long as you know that you are supposed to take the sum of the digits in the odd position and the sum of the digits in the even position should either be equal or differ by 11 or a multiple of 11. I'll give an example of a number. So we have a number like 2,596. 2,596. So we are supposed to find if this number is divisible by 11. As you can see, we are supposed to find the sum of the first, third onwards. So the first one, it will be 2 plus 9. This gives us 11. Then the other one, second and fourth. So if we take 5 plus 6, this will also give us 11. As you can see, the two sums are equal, meaning that this number is divisible by 11. Then we can also look at a number whereby we have to find the difference, 5,170. So a number like, 5,170. If we have this number, we are supposed to also find that this number is divisible by 11. So we're going to take 5 plus 7. This gives us 12. Then 1 plus 0. This gives us 1. As you can see, they're not equal. So we find the difference. The difference between 12 minus 1, this gives us 11. So the difference is 11, meaning that also this number is divisible by 11 because it has given us that the sum of the odd position numbers and the even position numbers are both divisible, have a difference of 11, meaning that that number is divisible by 11. So as I finalize, I'll just take you through the divisibility test as we've written them all the way from 2 up to 11. I hope everything was understandable. So as I can start, we saw that the divisibility test for 2 was a number is divisible by 2 if the last digit is either 0 or an even number. For 3, it was a number is divisible by 3 if the sum of the digits are divisible by 3 or form a number that is divisible by 3. Then by 4, this number is divisible by 4 if the last two digits are either both 0 or form a number that is divisible by 4. And we saw examples of 600 and 532, whereby 600, the last two digits were zeros, and 532 formed the last two digits were 32, which was divisible by 4. Then for 5, a number is divisible by 5 if the last digit is either 0 or 5. We can give an example of maybe 125. The last digit there is 5. Then the next one, a number is divisible by 6 if the number is divisible by both 2 and 3. So for you to know a number is divisible by 6, you have first of all to know that those numbers are divisible by 2 and 3. And to know that they're divisible by 2 and 3, you already have the divisibility test for both 2 and 3. Then we go to the next one. We didn't have the divisibility test for 7, so we're going to do for 8. For 8, a number is divisible by 8 if the last 3 digits form a number that is divisible by 8. And we gave an example of 2,144, whereby the last 3 digits, the number formed there was 144, which was also divisible by 8. So the next divisibility test was for 9. A number is divisible by 9 if the digit formed, or the sum of its digit, form a number that is divisible by 9. And we also gave an example of 594, whereby the sum of those digits gave us 18, which 18 was divisible by 9. Therefore, our number 594 was divisible by 9. Lastly, the divisibility test for 10. A number is divisible by 10 if the last digit was 0, and we gave examples there. That one was simpler. And lastly, we did for 11. A number was divisible by 11 if the sum of the first, third, fifth, or the numbers in the odd position odd position and the sum of the second, fourth, sixth in the even position are either equal or differ by 11 or by a multiple of 11. And we gave examples. The first example was 2,596, whereby the sum of the digits in the different positions were equal. And lastly, 5,170, whereby the sum of the digits gave us a difference of 11, which makes those two numbers both divisible by 11. So that was our topic for today. I hope you had a nice time, and that is how we tackle divisibility tests for numbers, and that is Form 1 work. Thank you very much. Have a nice day.
Beats Production.